Where's that?
Is it working now? Can you see something now? Hello, hello, hello.
Oh, yes, I can see myself looking at my own phone. There you go.
Oh my God. So, hello everyone. I think Facebook really does not like me. Daria and I had started chatting because on my screen it said we are live until some people messaged me, why are you not live? And then we tried logging in, but I have the feeling we might finally be live now. How weird is that? I didn't have just to say go live on one computer. I had to say on the other computer as well go live, which does not make sense to me at all. Um, It seems to be working. Okay, yes. Sorry everyone for everyone who's late. Yeah, Facebook and Zoom don't like each other, I think. But yeah, finally we're here. So yeah, we're gonna talk about healthy air, healthy home, the air tightness conversation. And I have Daria with me today, and I feel very sorry that you have to do the same spleen again. But what I'm gonna do is we're just gonna get Daria to introduce herself a little bit and tell us a little bit about herself, how she got into the building industry, why she is passionate about healthy home and air tightness. And then at the end, we're gonna have a bit of time for questions. But also, if you're watching the recording, please and have any questions, please put them down in the comment section, and Daria or myself can get back to it. So, take two. Daria, can you please give us a bit of an intro about yourself?
It's always awkward talking about yourself. It's even more awkward talking about yourself twice in a row. Um, okay, cool. So, my name is Daria. I've been in the high performance and passive house sort of world for over a decade now. Um, Essentially, I sort of review whole projects and look at how airtightness, as well as ventilation and insulation, how they all work together, whether you're likely to trigger potential problems in a building by perhaps chasing airtightness and not understanding that you have actively pushed yourself into a space that needs mechanical ventilation. Obviously, we've come out of in Australia with the mentality that we need to work our windows sort of more solar passive.
Mhm.
To open all your windows the moment the sun goes down to get a cross flow, all of that sort of thing. And there's just a lot of misinformation in this space, as well as just chasing minimum building standards that
Mhm.
don't actually talk about the system as a whole, how a house works and how it all interrelates. Um, so um, Essentially, I've just always been passionate in this space. I'm a builder's daughter. I spent about nearly a decade as a strata manager and found fascinating sort of leaky balconies and apartments that always had condensation issues and mold. And that was sort of before I understood why. And then about a decade ago, I had the opportunity to work for a company called Laros, which is a high performance engineering firm that's been around for uh, quite a while. And that's really given me the chance to learn about how this high performance stuff all works, how to identify problems, how to put forward solutions, and how to get in front of what would otherwise be a bare minimum sort of building standard. Um, so yeah, that's about me in a nutshell.
That's great.
Yeah,
Yeah, so yeah, and also just apologizing if I look to the side, I'm just looking to the other screen if there are any questions and if the live is still working, that we're not dropping out. But yeah, could you maybe give us a little bit about intro, what is air tightness? Why is it important for a healthy home? Or just a little bit of a general explanation, and then we can dive in a bit deeper.
sure. So I suppose first and foremost, a lot of people understand a drafty house is a cold house or a warm house. If you're up in the warmer areas, we all want a California bungalow that's really well ventilated with a bunch of louvers, and you never actually seal it up because you want that cross flow. Equally, in colder climates, we know we have to draft proof. So the aim of the game is to seal and putty and um, every single possible crack. We understand that that stops that draft and that cold feeling from entering the house. What we don't typically understand or speak to, because it's not really a well-taught space, even from a design and build perspective, is how you actually test for airtightness and what those values actually mean. So when we're talking about airtight buildings, what we're actually looking at doing is putting a blower door test on a building and pressurizing and depressurizing a building and understanding where all these leakage points are coming from. They come typically from penetrations like your power points, around your windows and doors, your extraction fan in your bathrooms, all of these sort of spaces. It's all a bit abstract when you get a number, because what is in a number? However, a typical Australian house sits anywhere from about 15 to 20 air changes per hour. So that's, you know, potentially 20 times the total volume of the building in air moving every hour. So cycling. So the moment you turn your heating or cooling off, you've already long lost that temperature that you've pushed into your building to make it comfortable, which is why we run our air conditioners for as long and hard as what we're used to. It's also why in the dead of summer we have in the peak of summer we have to keep running our aircon, because we're actively competing with, you know, sometimes 40 degrees or whatever the case may be, from getting into the house. So all this talk about airtightness and insulation, firstly, I think the biggest misconception is that this is for cold climates. So often the thing that most people kind of are most resistive about is, oh, well, we're not in, you know, Europe. We don't have minus 20 degree days. And I would argue, you know, we have bloody hot days down here in Australia. So it also is really good at keeping the heat out. That can all be done by basically trying to minimize how much air leakage is coming into your building. So if we're saying our benchmark for a typical house is somewhere in that 15, 20-ish mark, air change mark, the moment you get down to about 10 air changes, you can start kind of regulating the space. However, you start pushing your building into problem areas where essentially you can create condensation issues through lack of natural airflow, because your house, which was formerly a colander as a roof and walls, suddenly is not quite so breathing and airy. So you start having issues when you can't dry out all this moisture that we create. This happens by having you know, something as simple as single glazing in a colder climate. So I'm from sort of that Canberra region, so it gets quite cold. If you're sleeping in a single glazed bedroom and you close your door and it's -5 degrees at night, it is definitely cold enough that you wake up and your window is covered in condensation. And where there is that kind of moisture buildup, the mold will follow. I think anyone along sort of most of the East Coast actually is very familiar with mold forming, and often there's a focus that it's to do with physical water sitting on surfaces, not that we're actually not ventilating the space correctly. So,
and I think if I just can jump in, and one misconception is people always think the water is coming somewhere from the outside. You know, why should I have mold in my home? But the humidity is actually coming from us just by breathing, showering, indoor plants, or if you dry your clothes inside. You know, my professor at uni, he would scream. He always said, "You can't dry your clothes inside." You know, just very extreme. So it's really, we're creating this humidity. It's not that there's necessarily a leak or a gap outside where water is pouring in. It's just happening from the inside.
Absolutely, and it's also happening because more often than not in along most of the East Coast, you've got enough of a temperature differential that you will have a point of condensation, and it's going to go for thermally the poorest performing element, which more often than not is single glazing or non-thermally broken aluminium frames. You know, we we use a lot of building materials that are very or highly conductive, if not the most conductive metals going, which is a thermal bridge, and it's just bringing whatever is happening outside inside. So it can be a problem, most definitely. So we're getting better in that space, though. I think more universally, look, let's be honest, Grand Designs has done a lot for the high performance world. We've all watched those shows where, you know, they're trying to do above and beyond, and often to those high performance European or German passive house standards, and they can do really extraordinary things. However, I think when building in Australia, it doesn't always have to be to that nth degree. And we can actually be doing really remarkable things in our buildings just by designing and thinking through, you know, how you go about your renovation or how you go about your new build, so that you can design in just, you know, those core principles of, you know, high levels of insulation, airtightness, remove that condensation issue, make sure that the thermal envelope, the shell of your building, the one part of your building that you're least likely to ever redo, is done correctly. We can always change a kitchen benchtop at a later date, but you're unlikely to remove the walls or the roof of your house and redo that properly. So that's the one part that you really should be trying to get right. Obviously, in a new build, you can achieve a lot more. However, even in a renovation, there are really good ways where you can, you know, chip away at a house that's otherwise pretty poorly performing and slowly start improving it. My little house is a really good example of that. I have a 30-year-old heritage cottage that I've gutted internally, left the brickwork, gutted internally, run some hydrothermal, so moisture calculations on the walls, found the best way to insulate them so I don't create problems, because as you start changing build-ups, you can create problems that you never had before. And now I have a little house that I run the air conditioner maybe an hour or two a day in the dead of winter for maybe a month or two. And that's enough to just temper it to my comfort level. And in summer, as long as I keep the doors closed, it stays pretty cool. So there's lots of ways you can go about improving your house beyond just your simple draft proofing and, you know, door stoppers and things like that.
But it's such a big difference, you know, if you have a well-performing home, you know, like you said, you just have to warm up the house, or you now cool the house in summer, and it stays like that for several hours. It's just a phenomenal concept that, you know, most Australians, I think, have never realized that. And I find it so shocking, especially in the in-between times. You know, you have it's hot during the day, but cold at night. And I speak with so many friends, during the day they put on the aircon, and at night they have to turn on the heater. And it's just like, it's unbelievable. You know, it shouldn't be like this. Your house should be able just to keep a bit of a general temperature for at least for a little bit.
That's it. So it's about creating an inner stable environment rather than, yes, you can always put solar panels on your roof, and that's a good thing to do, and, you know, have a big aircon system that actively heats and cools your house. But if you don't need all that energy in the first place, and you have something that's just really nice and stable, you know, I'm pretty stoked that a little 3.5 kilowatt air conditioner that turns on at 6 a.m. so that by the time I'm out of bed, my house is just that little bit more toasty warm in Canberra, where it does drop down below -5 even. I think that's a great result for a renovation.
Definitely.
Couldn't be happier.
And if you think about it, you put on a good topic, you know, many people argue, why should I make my house energy efficient? I just put as many solar panels under the roof as I can. Who cares? You know, free energy, I just heat my house. But the problem is, say, if you have a 40-degree day and, you know, your aircon blasts throughout the day, and then at night, if it doesn't go below 30 or something, or stays on 28, your house warms up during the night, and then you have to put on the aircon again, and you have to pay for it, or vice versa in winter. You know, it's the coldest at night. But if you turn on your heater at 4 or 5 p.m. when the sun goes down, what do you do then? So I think that whole argument doesn't really hold up.
No, it doesn't stack up. No. And especially with like some of the crazy weather that's happening around Australia, not to be like a doomsday or anything, but, you know, we've had some really extreme weather events locally. We've had all those hailstorms, and sometimes feel like it's literal hail and brimstone happening occasionally. And when the power's out, it's nice to have a house that's still fairly comfortable. It might not be exactly what I want it to be, but it's a hell of a lot better than, you know, letting that 40-degree heat when the grid is stressed in those extreme temperatures. That's when you want your house to be the most comfortable. Equally during the bushfires, it was really nice to see, even as a construction site, an airtight building was the best place to sit in for indoor air quality and just hide away from all the smog. And, you know, Canberra was, I think at one point we were the second smokiest recorded air in the world. And yeah, I had a lot of my girlfriends over with banana lounges and wine, and we sat in the construction site with all the dogs and all the girlfriends drinking
nice
wine.
fresh air.
And fresh air, and we were doing better than a lot of other people, I think. So it was good to see play that you know, we had that ability to so it's not that you can't open your windows, it's that when you don't want to bring the outside in, you have that ability to regulate it and shut it down and keep whatever, you know, inert stable temperature is happening inside and keep what's outside, which is a great thing to be able to do at times.
But I guess an important thing we need to talk about, you know, so when we're talking airtight homes, you know, where is the fresh air coming from? So I think we should talk a little bit about that, because you need fresh air, and B, we have to get rid of the humidity.
Yeah. So there are a few different parts to this equation. We're not talking about hermetically sealed buildings to the point where if you don't turn on a ventilation system or don't crack a window open, you're going to die overnight. Nothing but that airtight. However, you want to keep the indoor air quality at a good level. So because we're breathing, we're creating, you know, pollutants in the air. Dogs, they're pretty smelly creatures too. There's all these things in the air that we don't want to be necessarily rebreathing. So this is where the difference of an air conditioner or a recirculating air system versus a, you know, energy or a heat recovery ventilation system comes into play. So this is a method where you can essentially be extracting all your, we'll call it stale air or bad air out of your building, and you're bringing in fresh air that's thermally treated to similar to what you've got inside already. Again, not to say you can't open a window. It's just if your house is sitting at, say, 25 degrees in the middle of summer, you are going to be much less inclined to open that window for a bit of fresh air if you know, it's 38 degrees outside. You're not going to do it. We inherently are lazy creatures. If we're comfortable, we're not going to do it. Let's be honest. So so we have this way where we can ventilate. However, obviously there are trigger points where these systems rely on a certain level of airtightness before they will work. And this is where the unraveling of airtightness kind of becomes a little bit more complicated. So, you know, it's quite attainable to build something very airtight by a builder if they're meticulous and careful, whether they actively mean to push it into a problematic airtightness space. Same as, you know, mum and dad renovating and draft proofing. It's easy to push a building into a level of airtightness that you weren't aware suddenly creates a trigger point.
So what would you say, what is the critical level of airtightness when people really need to consider ventilation?
So there's sort of no hard rule. I think as high as 7 air changes starts creating problems, only because a house does not equally have airflow coming from all sides of it at all times. So even though 7 air changes is quite air leaky, there are rooms that will not have active air being pushed through them. There will be rooms where a couch is against a wall, so there's no room for it to breathe behind it. And it might be the south-facing wall, so it's already a bit more damp. It's a little bit more cold. There are lots of reasons why it could be a little problem pocket,
Yeah.
per se. You know, I think quite universally, a lot of us say 5 air changes. I've seen problems at 7 air change houses in that vein. And then at that kind of grey zone, you also run the problem that ventilation systems often are not designed, at least the ones coming, the high performance ventilation systems aren't designed to be competing with that much air leakage. So you then have the problem of, you know, the ventilation system is competing with the natural air leakage. So you may find you have to run at the higher setting or have a larger system or whatever to compensate for that air leakage to get it, you know, all the way across that room where you've got that problem. So you want to try and you kind of need to commit one way or the other. You're either, you know, the intent there is for airtightness, draft proofing, getting it, you know, nice and stable with the understanding you need the ventilation. They truly go hand in hand as a building methodology. You can't do one and not the other because you are guaranteeing yourself a problem essentially.
What I often say is to people, because I often speak with people, especially when you do a renovation extension, say, oh, you know, we don't want to spend the money and we're not sure if we're getting it airtight. And what I often say is, you know, if you don't want to put it in, at least get a really good sensor, a really good monitor that tells you, A, the CO2 and the temperature, of course, but also the humidity levels. And at least then you can see, okay, if the house gets too humid, you have to ventilate more. And if you realize we can't ventilate enough, then you can always still retrofit some of the ventilation systems. Because ultimately, mold is a very sneaky beast. It might be years before you see it, but it might be everyone has this nagging colds that don't go away, or you get skin issues or asthma and no one knows where it's coming from. And then, it can be years and years before you see the mold, and then it's mostly too late. But if you have a monitor that tells you what is actually the humidity in my house, then you can act before problems get too big.
Definitely. And you know, we're not talking really fancy monitors. IKEA even do a little thermostat, does your carbon, your moisture, and your temperature, and you can, you know, you can link it to your phone, and you can, you know, have a few of them around the house. So there are quite accessible. It doesn't have to be a really complicated monitoring system by any means. But yeah, as an extension of that, the other side is if you're doing work, say in your ceiling space, and you know you're trying to draft proof, say in a renovation, if you have the access and the ability, duct for it. Even if you don't commit to the physical plant equipment of the mechanical ventilation system, because often that is the expensive part. But even if you've got it there ready to plug in, maybe that's your next stage in your renovation works. We all work to a budget. That's the reality of life. You know, so if your intent is to get a house that's going to be better performing, and you know you're going to be chasing air leakage, because I think we all understand air leakage is energy loss. If you're going to start down that path, understand that as a partnership with Airtightness, you need to already make those provisions for your ventilation systems.
Definitely. But I'm not sure if that's something you know much about, but, you know, often people ask me, you know, those ventilation systems, you know, are they hard to maintain? Is that, you know, do you have to put lots of money in, or are they expensive to run? And, you know, there's still a lot of misconception about that.
Yeah, definitely. They're very cheap to run. So first and foremost, they're not an air conditioner. They're not kind of that brute force system. So they're really just there trickling a bit of air in and out at all times. The systems themselves, there's a wide range from decentralized small little push-pull kind of systems that go in the walls. So they're really good for retrofits where access is maybe limited. All the way up to kind of your more sophisticated ducted systems that, you know, if you're in a multiple story house, you need space for risers and the plant room and this, that, and the other. So it's quite a large scale of how expensive a system can be. But there's definitely lots of different options there. I've seen some renovations over the years where they've actively targeted kind of the problem areas first with the little decentralized systems and just slowly chipped away through the house. And that's come off the back of some basic draft proofing and caulking around all the windows and doors. Eventually
Nice.
got some better windows and doors that were double glazed, so suddenly it's already more sealed. And suddenly they've gone from this house that was really uncomfortable to this house that's a bit more comfortable, but suddenly has condensation issues and mold issues. So you just have to go into it, with your eyes open, I guess.
Yeah. And I guess that's a good lean over to, so a question, if someone can't afford major updates or upgrades to a house, what are some small things they can do to improve, air quality or, the efficiency of a home? You just scratched on that a little bit.
Yeah, I mean, it depends on obviously the type of house you're in and the, how it's been built and how old it is. And it's always a little bit of a can of worms with renovations. I know I definitely got some nasty surprises when I lifted the floorboards in my own cottage. So it is a dangerous thread to pull at times, but you also, we should be able to be in a house that's livable and comfortable and not making us sick. So there comes a point where, if that tipping point has been reached and you've decided you're committing to it, I think insulation is always, one of your low-hanging fruits. Just make sure that you check that the way you're going to insulate is going to be healthy for the buildings. As we add layers and materials into the buildings, we're changing the way they breathe or the way they dry. So it's really important that we don't damage the breathing ability of buildings. So in my case, I have a double brick cottage, and I explored blow-in insulation for my cold climate. And the modelling that I looked at identified it would probably be quite problematic, and it would cause more problems, more harm than good if I did that. So I ran a few other options, and unfortunately I'm heritage listed, so I couldn't insulate externally, but I could insulate internally. So internally, every single wall has been battened out with a little ventilated cavity, insulated, and that's let me have a house that, whilst my walls are incredibly thick, I've now pushed
European
all
style.
that cold thermal bridging. Oh, they're so deep. My doorways are like this. It's crazy. But it works, so I don't care because it's far more livable. But again, we all have budgets. Can't really see. Well, maybe you can see, but just over there, that is not a very high performing back door. I'm working on it because we all have budgets. So, but I've got the front door in, and I've got all the other windows and doors going. So
Nice.
there are ways to stage it. I just made sure to take lots of photographs as I was replastering, so I know what's going on behind it, so that when it comes time, I've got, the detail for, how I fit that door.
Yeah.
So it's just a matter of mapping out what is feasible, what your budgets are, having a chat. There are a lot of us consultants on the market, and designers that are across how to kind of do it a little bit more modestly or humbly as a renovation, where you can still get really good results. But yeah, the insulation is definitely a low-hanging fruit. Windows and doors are becoming more and more affordable every day. So, if you're going to do that, skip the glazing coatings and things like that. Just straight away go to your double or triple glazing, thermally broken. You've got to make sure they're thermally broken frames. Otherwise, it's really a waste of time and energy.
And money.
And money, definitely, definitely, and money. And if you're going to do it, you may as well do it so that it's, one and done. And obviously, if you start doing that kind of work, you are pretty confidently pushing your building into that area where you need to be considering ventilation systems. there's only so much physical, manually opening windows and doors to ventilate that it's going to do, especially, where I am, it's a hot heat wave day. There's no wind outside. It's very hot and there is no breeze. So at that point, even if your house is a little bit more air leaky, it's still worth doing the mechanical ventilation because it will actively create that airflow through your house and it will help with that kind of energy.
No, that's good. But you just said, you've done quite a bit of consultancy work and you were called in on construction site when things have gone bad. Could you maybe give a little bit of a summary, the good, the bad, or the ugly? What do you see when things go wrong? Or if things
I
go
think
wrong?
I think a lot of that comes down to the detailing. So it's builders committing to a project, not understanding what airtightness is or what they've been asked to deliver on. Not kind of figuring out how they're going to detail that properly before they start. Especially in a new build, it's your clean slate. You should be able to do this really easily. It just takes a little bit of effort and a little bit more time to just be meticulous with the way you put it all together, and a little less haphazard than what some builders are used to doing. But if you go in and build like bog standard and not realize that you do need to achieve an airtightness value, and I think that's where mums and dads need to be really clear that if they are conscious of energy efficiency and airtightness, you need to put a number on it and you need to hold the builder accountable to it somehow so that they understand what they're doing. And equally, the builder should be given sufficient detailing from the design side so that they understand how they're actually meant to deliver this airtightness. So there are lots of open source details around how you go about identifying where your airtight envelope is or your thermal envelope is, how you go about testing it. Things like infrared guns are now a hell of a lot cheaper than what they were 10, 15 years ago. So there's the technology there to kind of do the quality assurance. And I think that's really when you're building, especially if you're, trying to get that healthy building side of things going. We often fixate on energy efficiency and miss the health of the building side. The health of our occupant will naturally come if the building is healthy. But you can chase all the energy and efficiency in the world, and if you don't have the right detailing in your building design, you can still build something that will have interstitial condensation issues within the walls, so that the actual physical makeup of the building is going to be problematic. So you just need to understand, and I'm not talking here about reinventing the wheel. You can have a healthy building that is your quintessential ColourBond or brick veneer or weatherboard house. It doesn't actually matter. You don't need to have radical building technologies to get it to perform really well. It's more so in understanding how all these materials work together, and that you're putting them in the correct assembly, and that you're understanding that this wall assembly and this level of airtightness and this ventilation system, they're all going to work harmoniously. And that's how you understand what you're detailing. And then the real magic to it all is there are methodologies that let you test that what you have designed to is going to actually be what's delivered, so you can expect that comfort out of it. So that blower door test that we were talking about earlier, and that is how you understand that for all your want of an energy efficient house and an airtight house, that's how you test to find out whether it has actually achieved that result. And if not, it might not be the end of the world. Adjust the numbers. There are different thermal assessment tools on the market. Let it reflect what airtightness you actually got, see if it means something has to change in maybe the ventilation system, or maybe you need a slightly bigger air conditioning system to compensate for that energy loss. But at least there are ways to actually calculate these things.
And I guess during the blower door test, you can go around the house as well and see where is it actually leaking. So you might be able to identify a few problem areas.
Yeah, definitely. The value is not actually so much in the number. It's while the equipment's running, you can identify all those leakage points really easily. And if you have access to it, if it's not yet plastered or whatever else, and you can run around and access those air leakage points, just keep sealing it up. If you can get to 2 or 1 air changes, you will have a really stable environment that now whatever energy you start putting in is what stays in the building envelope.
One thing what I've seen a lot as well is happening kind of accidental air tightness, especially with apartment buildings going up. They're often done with precast concrete, so the walls itself are just accidentally airtight. And then they have, often thermally, just normal aluminium frames, because just looking at the energy weighting, they get those apartments up to 7 stars. And then suddenly there's all this trauma because there's so much water inside and so much mold. And I heard especially stories in a city where sometimes 4 or 6 students share a small apartment just in order to save money, and there's lots of water, lots of humidity, and everyone is screaming that the water is coming from the outside. But it's just that same thing, accidentally airtight, and no one thought about the ventilation. So
I guess that's where there's a divergence in kind of ways you fix this, because I think most Aussies understand dehumidifying. So I would be surprised if there's any Aussie on the East Coast that hasn't had one of those mold silica buckets on their window at some point in their life. But that is super gross, because it's actually just holding and festering all of that mold in it until you throw it out and put another one in there. The beauty of your mechanical ventilation systems, there is natural dehumidification that's happening in that energy exchange. So you're within its extraction stage, it's actually taking those impurities out, and it's bringing the fresh air in through filters as well. So you're actually getting to the point where you're achieving that dehumidification with the fresh air, as opposed to keeping that stank air in the house, in a mold bucket or in a dehumidifier that you have to physically pick up that bucket and pour it down the drain, which can't be good for you. But that's just such a band-aid approach, when a lot of it can be resolved with, strategically placed ventilation systems that will ensure you've got that air exchange happening. And at that point, you just need to keep on top of your filters. No different to your air conditioner. You want to be doing that probably every 6 to 12 months, depending on where you live. We get a lot of dust storms down this way. So generally it's, I try and clear filters if I know I've been hit by a red dust storm, because I know it's going to be blocked with it. So it's just about being proactive with that, and then at least it works. But it's a slightly different methodology, much the same the way solar passive and passive house are different. There are certain building methodologies that again, this is that kind of nuance that starts happening, where people go, oh, I want the thermal mass of a solar passive house, but I want other aspects of passive house technologies. And you can actually really create hell of a Frankenstein, where you have this, big body of thermal mass, which is an energy battery, essentially, that you've put in a building envelope that's inert and has minimal heating and cooling losses. So suddenly, if anything is wrong with your thermal mass battery, the physical energy you have to push into that, you have to drive into that before you can, restabilize the ambient temperature inside the house. You're not just topping 2 or 3 degrees. If your thermal mass has compounded over summer and you've actually got to draw 12 degrees out of it, you need to punch a lot more energy into that thermal mass to regulate that before you can affect your thermal envelope properly. So there are these sort of conflicting little points and triggers through building design, and I think that's really where that value of assessing and understanding and talking with designers that know what they're doing, and how these things all interrelate, because it's a complex sort of matrix on how it all works together.
And that's a good lean to one of the questions that came in prior. What's the best time to think about airtightness during the design or the build process?
Design, always design. The sooner the better. The sooner the better. The sooner you can start this conversation with your designer and have them clearly understand that this is a priority, that the health and byproduct of energy efficiency are critical to you, the less wastage you will have in drawings being put together and then you're changing them. There is an impact in, it's your quintessential Venn diagram, right? You can have, if you've got all the money in the world, none of this is a problem. But if there is a budget, and there is,
most people have a budget,
a goal, I know, right? You need to be really clear with what the priorities are, and sometimes it will be the difference of a little bit more glamorous architecture if you want to get other detailing right. And some of this it's about reappropriation. I'm not saying it's necessarily horrendously more expensive. I'm saying you front load the detailing, the drawing, and also during the build process, you're putting more energy and more material into the building envelope to get it to that higher level of performance. And further down the track, that's when you get the slightly cheaper air conditioning system, or your solar doesn't have to be quite as big as what otherwise have to be. So it's about where you push and pull the money so it goes into that thermal envelope, so it's working right.
Exactly. And I often say, rather than putting the money into the bling, you don't get the granite benchtop or, the handmade tiles from Italy. You spend a bit more on your whatever windows, on your insulation, and then you get some local simpler tiles and you just pimp up the place with some paint or a nice artwork. So
and that'll be outdated in 10, 15 years anyway. So then you'll be redoing it regardless. Whereas your thermal envelope, if you get that wrong,
like you said, you're not going to touch it again.
No. One and done.
I have another good question here. Where was it? How can I tell if my builder actually understands airtightness and ventilation?
How do
I check them?
I think if they're willing to put quality assurance to it, so blower door testing, smoke testing, if they can kind of explain to you how they're planning on achieving the airtightness. It's difficult because in this open market you've got a lot of builders that they want the work and they'll say, yep, I can do it. So you just need to find people that are proactive and want to do better, because realistically the benefit of doing this airtightness is for the homeowner. And if you align yourself with a builder that ultimately doesn't actually really care or understand, it's going to be an uphill battle. And if it's not contractually locked in, they're not going to do it. So a lot of it is around, if it's vague wording. So if they go, oh, we will attempt to make it airtight, and they're not willing to put a number, I would be concerned. That to me says they're going to kind of say, oh no, well, we put some foam around the windows. That was the airtightness. Yeah. It's just wishy-washy. If they're willing to put a number and chat with the designer and settle on a number, be it 5 or 2, aim for 3. 3 should be really attainable without too much effort. And if they're willing to commit to a 3 airtightness with the blower door test so that you have a known variable, so be it. There is a bit of resistance in the market for it, because at the moment the construction code mandate is that you know, you don't have to do an airtightness test, but if you do, you need your building to be under 5. So there is a little bit of kind of that scary factor to builders where
Isn't it still under 10?
no, so if you have to be under 10. If you're under 10, if you're under 5, you have to ventilate.
Yes.
System. So there is a little bit of fear there that you know, especially if they've never done a blower door test before and they're not sure if maybe they're actually not able to deliver to a 10 air change. I've known builders that have achieved less than 2 air changes just with external, just being meticulous on external wraps, and been like, oh God, now I have to cut, you know, freshly painted plaster and retrofit a ventilation system because they've realized they've you know, unintentionally
did a good job.
yeah, done too good a job, and I didn't test earlier on in the piece when the plaster was not yet on, where that would have been a lot quicker and cheaper to have installed ventilation system. So it's largely about sequencing and understanding when you would do something and how you go about it.
And another good thing I found with builders as well, how you can question them, that if you ask them, you know, if they have done a sustainable home before. And if someone starts talking about, oh, we have done this really energy efficient 6-star home, and then you ask, yeah, so what did you do? Oh, yeah, we put solar panels on the roof and a rainwater tank. If that is the only thing they say, then you better turn around and run, because that's not really an energy efficient home. That's just bare minimum building standard, building code. So, you know, that they should go at least into a bit of detail, how they made sure the insulation was done properly, how they had tried to get the house airtight or something. They have to go into a little bit more detail than just saying solar panels and rainwater tank. That's not a good start.
No. And the 6 stars really is the minimum, not the benchmark. Like it's not.
I mean, a few years ago, 6-star was kind of, you know, But
oh,
now
we say that it's been 13 years since 6 stars was legally the worst you're allowed to build. So it's not that amazing. But yeah, it's you're right. There's something in if they're not, again, it's in that quality assurance. So if you're wanting higher levels of insulation, you know, write into the contract that you want an infrared camera put over all the walls so that you know it's been installed correctly. Shouldn't cost a lot, shouldn't take a lot of time, but even just that in the back of the builder's mind, knowing there's that rigor, you know, you're not going to have kind of insulation peeling out of walls, and yeah, I've seen some pretty interesting installs for insulation over the years.
Good. I have one more question here from the live, and then so maybe if anyone has any last questions, please put them in now. Hi, I'm in Melbourne. Are there any dangers to designing my home less than 6 air changes per hour and not increasing the insulation? 90 mil stud frames typically used here. Limit the level of insulation. Do you think we need to be looking towards a wider frame? Are there any other options out there?
Good question. So yeah, so 90 mil frames, even if you chose a high performance insulation, but at most you're only going to get an R2.7 in there. If you can at least enable it to be airtight, you are more likely to get the performance of the R2.7. But again, that air leakage compromises the insulation performance so drastically that is why we have 6, 7, 8 star buildings that still need a big air conditioning system, because the air leakage is what actually destroys the insulation properties. So when you're looking at performance of insulation products, you have to remember that is its maximum value that it's been tested to in an airtight environment. So if you want to get that value or remotely in that realm, you need to lean into the airtightness. You will always get a much better, you know, performing wall if you can get more insulation in there. If you can get 2 R2s, you're pretty well insulated almost anywhere along the East Coast. However, I understand sometimes there are limitations with. Sorry, my. Sorry about that. I have two big dogs and they've just had a postman pop by. Yeah, so obviously if we can get more insulation in, that always looks that's always going to get a better performance out of building. The reality is there's only so much you will ever get thermally out of a 90 mil frame. So it's really about understanding that there are compromises there. So with the 90 mil frame, you will not be at kind of a high performance level, even if it's airtight. The overall thermal loss through it will always be quite high. So if you can find it in your budget to do a double frame or, you know, even say a 110 mil frame with a high performance that gets you up to R3.1, that's already kind of significantly quite a big incremental jump without losing too much in your overall footprint for your walls. So there's different ways you can work it out. It's really in understanding how you go about assessing the difference, the different performance across those different walls and how it's going to impact your heating and cooling loads, how it's going to impact your overall comfort and stability of your building envelope. So it's just a matter of making sure that you look at getting it assessed.
Nice, that's good. Before we wrap up, Daria, any things we haven't spoken about or any other tips you want to give people?
Look, I think if you start the conversation sooner than later in the design process with, you know, consultants that are across kind of healthy building practices, there's a lot of greenwashing on the market. So I understand it's a difficult thing to navigate. Obviously, the gold star in that space is Passive House. But there is a lot of really good building practice that can be done, you know, at a lower scale back version of Passive House. So really it's just in understanding how or what you can get out of the budget that you've got set, what's realistic, how to map it all out. So I think the earlier you can get, you know, a high performance or Passive House consultant involved before you go into sort of the minutiae of the detail even in the design stage, I think it's really valuable because at least in my experience, a lot of the consultancy that I do ends up, you know, me redirecting designers that have already charged the client significant amounts of money because the brief and the priority around the energy efficiency is conflicting with the design detail that they've drawn. So I think if you can, start that conversation really early on in the piece. I think there's huge value in the design analysis of Passive House certification process. So the design analysis, that front end design detail, is actually a really dynamic tool that lets you model a design and run variables and see, you know, where is your best bang for your buck. And that would be where you would find out whether the 90 mil, you know, what that compromise of a 90 mil frame versus 140 or even the 110 and the level of airtightness, how that will impact. And, you know, you may find that for $10,000 more, you can get the much better performing thermal envelope, and it's going to already be offset within just with how much smaller your air conditioner has to be. You won't really be able to assess that with a lot of kind of the more rudimentary Australian thermal assessment tools that kind of don't down to that micro detail. So it just depends on where you stand with it. Otherwise, there are just some really good overall principles to sort of chase, and if you do that, you'll have a really good performing house. It might just it's more about just aligning expectations, I think, which is why I really love the design analysis and the quality assurance side of Passive House, whether the certificate is the critical part. You know, I know I don't have the money for that for my own home, but you can follow all of that and know you've got something really comfortable and that's going to be inherently healthy to live in. Yeah.
Definitely, yeah. I'm a huge Passive House fan, as most people know. And like you said, Passive House is kind of the golden standard. But I believe as well, you know, A, not everyone can afford, you know, getting the house to Passive House standard, and B, you don't always need it. But I think as well, you know, at least doing the initial Passive House calculations, like you said as well, to optimize the insulation levels, to check out different windows. And you can actually scenario test it, and you can say, okay, if I only do the 90 mil stud wall, what does it mean in terms of energy usage? If I go to the 140 mil stud wall, what does that mean? And then if you have a builder, you can discuss with the builder what's the additional extra cost, and then you can make much better informed decisions. And like you said, you know, even a house with a air exchange of 1, 2, or 3 can be a beautifully, you know, amazing, healthy home, much better than pretty much all the homes out there. So, you know, it's not, I think people don't have to be too scared, oh, you know, I have to go to a Passive House or nothing. There are so many nuances in between, but, you know, like you said, I think the big thing is as soon as you talk about air tightness, there needs to be some sort of ventilation. It's just physically impossible to open the windows often enough to get the humidity out. And
yep, absolutely, for sure.
That's great. Thanks so much, Daria. And yeah, if you watch the recording, please put, you know, questions down there and tag myself or Daria, and we can get back to you. And yeah, apologies again that we were late. Like I said, Facebook is not my friend, or Facebook and Zoom are not friends. But I'm glad that we managed. And yeah, thanks so much, Daria.
No worries. See ya.
Bye.